Hi guys, this is my third video on electrical circuits and my first video on mesh analysis. We'll be using mesh analysis to find the current going through the branches of this circuit. The first question is, what is mesh analysis? Mesh analysis is essentially Kirchhoff's voltage law, KVL. And what we'll be doing is just using KVL on the loops we have with mesh currents assigned to each of these loops, 1, 2, 3. It is the same as the regular KVL, Kirchhoff's voltage law, you used to applying on circuits. The only difference is that you find the branches in between each loop in terms of the mesh current, and that's just it. Everything we'll do is the same KVL with all the inner branches expressed in terms of mesh currents. So the first step you want to take is to assign mesh currents. Now, I'm just picking directions arbitrarily. I can decide to go counterclockwise, but I'm just assuming that all my mesh currents are, going clockwise, right? So I'll call this I1, I2, and I3. What this means is that this loop has a mesh current I1, this loop has a mesh current I2, and this loop has a mesh current I3. Now, the mesh current is the current that is on the outer branch of a loop. So if you look at this loop 1 here, the outer branch starts from here. So having assigned this mesh current I1 for this loop, it means the current through the branch, outer branch. So when I say outer branch, is a branch that is not shared. So this is a branch shared by this loop and this loop. So it's not an outer branch. But this branch is only owned by this loop. So that's the mesh branch. I don't know if that's what it's called, but having assigned this current, it means this current is what's flowing in this one. That's just what it means. Now, we have this second loop and we have this outer branch. It means the current in this outer branch is flowing like this, because this is the direction we chose, right? I2. Do we get it? Mm-hmm. And then the last loop is this one. It is flowing counterclockwise, in the clockwise direction, and this is the outer branch, right? It means the current in this outer branch is I3. So instead of assigning current for the inner branches, we have one inner branch which is between loop 1 and loop 2, this inner branch which is between this loop and this loop, loop 1 and 3, and then we have this branch which is between this and this. Is that clear?
Yes.
Now we need to find the current in each of the inner branches. So we'll start with this branch. If this current is flowing out of here, because it has the clockwise direction, right? Mm-hmm. That means, let's just assume, I can just assume that the current in this branch is I branch 1, right? Mm-hmm. So notice this, I2 is flowing into this branch. I1 is flowing out. So I2 is flowing, so I can say for branch 1, inner branch 1. So I'm talking about this branch, inner. I have I2 flowing in that node here, and I1 flowing out, and I branch 1 flowing out. So what I'm doing is applying KCL on this node. I'm just labeling it so it's easy, but in mesh analysis, you just skip all this step when you know what you're doing. So I branch 1 is now I2 minus I1. So instead of having a newly defined current here, you just call this current I2 minus I1. So every inner branch is expressed in terms of the what? Mesh currents. So we've been able to express this inner branch in terms of the two mesh currents that is coming in. Now we go to this branch. This branch, let's see. This branch, we have a node here. And this node is weird because of this. It's going to be a little bit tricky. From what we know already, we treat this typically as one node. The whole current that flows. So let's just do this. I'm going to pick a direction for this guy. Okay, yeah, we don't need to worry about this first. Look at this node here, N2. Let me call this N2. This current is flowing into here, right? So KCL on N2, where N2 is this one. This mesh current is flowing in, I3. This mesh current is flowing out, minus I2. I can just call this I branch 2, right? It's flowing out, so I can pick any direction. I branch 2 equal to 0, right? So we can solve for I branch 2 in terms of the mesh currents. What it means is that this I branch 2 is the same as I3 minus I2. Is that clear? What branch is left? Okay, so we have a mesh current in this branch, outer branch, I1. We have a mesh current in this branch, I2, outer branch. We have a mesh current in this branch, I3. This inner branch has the current expressed in terms of the mesh currents, right? And this branch has current expressed in terms of the mesh current. The only one that is left is this, but we don't care about this because we don't have a resistive element here, so we don't need to find IR, so we ignore that. And that's why it makes it easier to ignore that one. So essentially mesh analysis is just KVL plus KCL. KCL for each of the inner branches with resistive element to find the what? Current going through them in terms of mesh current. So I will just label more. I'll call this, let me use a different color. So I'll call this mesh 1. That's mesh 1. This is mesh 2, right? And this is our last mesh. Mesh 3. I know most times you just keep this in between steps and just think it through and say, okay, let's pick one direction and just deduct it and do the algebra in your brain. But this makes you check yourself to be sure. Essentially, how you find these ones are KCLs, right? Now, the last step is to apply KVL for each of the loops. So we apply KVL on each of the loop. We start with loop 1, right? Loop 1. It could be written as mesh 1, right? So let's see. We're going clockwise, right? So we travel the direction of the mesh current. So let's go this way. We hit this on the negative and then go positive. Is it positive or negative?
Negative.
So we're hitting it from negative to positive. You sure? That is negative? Okay. That means it's traveling this way. It's negative 6, yeah, because you're writing it on one side, yeah. Yeah, so it's negative, because if you were writing summation of EMF is equal to summation of potential drop, then it's positive. But you're doing summation of everything is 0, makes it negative. I always mix that up. So yeah, so we're going negative to positive, makes it negative, and then we'll go here. We hit this element. This element has this current traveling in it, right? So plus 2, but the current, we chose this direction, but we're traveling this way. When you're going opposite the direction specified, it's gonna be what? Negative. Minus, right?
Yeah, negative.
So actually this will be minus into what? I2 minus I1, right? And then we continue going, and we hit this guy, which is the same direction because we purposely traveled the same direction with mesh. So plus 10 I1 equal to 0, right?
Right.
If we rewrite this, let me just conserve my space. So we had minus 6 minus 2 into I2 minus I1 plus what? 10 I1 equal to 0. It implies that I'll rearrange this. So this multiplied by this will give me 2I1 plus this will give me 12I1, right?
Right.
Because this becomes positive, and then we have minus 2I1 equal to 6, equation 1. I just moved that to the other side, added 6 to both sides, right?
Right.
Done with loop 1, also called mesh 1. So we go to loop 2, or mesh 2, right? So same thing. This is 2, so we're going the same way, like this, right? So let's go this way. We hit this guy, right? The current flowing through this branch is going opposite the direction we're traveling.
Right.
So it will be negative 1, right?
Yes.
Bracket what? That current, which is in terms of the mesh current, right? Then we hit a source, positive to negative. It's going to be what?
Positive.
Positive. Perfect. Plus 8. And then we continue traveling, and we're traveling in the same direction as our mesh current, right? So we're going like this. So we hit this guy. We have what? Plus 4I2. I just want to conserve space. Sorry. This is I3 minus I2 plus 8, right? Plus 4I2. We're here now, right? And then we go here. Now we're traveling in the same direction as this one, right?
Yes.
We have to go round like this, right?
Yes.
So we started here, we have to complete here. So we have plus what?
Plus
2 into I2 minus I1, right? Is equal to 0. Implies we're going to rearrange. We start with I1s. 2, 3, 2. So we have just this I1, right? So we have minus 2I1, right? This multiplied by this will give me I2, right? Plus 4I2, that's 5I2 plus 2i2. That's 7
I
plus 7
I2.
I2. Let's see. I don't want us to miss anything. So this and this 6 and then 7. Then remaining I3. We don't have I3 anywhere else except here. So minus I3, right? And then we have 8. We can move it to the other side. So we have equal to minus 8, right? Equation 2. Minus 8. Let me just use a different color for the equation number. So, okay, perfect. Now we have our last loop. And we're pretty much done. We just solved, right? So, loop 3, mesh 3, right? So we're traveling this way also. So let's start from here. We hit this plus minus. Plus, right? If we're going minus plus, it's negative, right?
Yeah.
So plus 6, right? Plus 6, right? And then we keep going like this. We're traveling this way. We're going the same direction as this current because the mesh direction is, we always maintain the same direction as mesh, right? Mesh current, it makes it easier to keep up with your convention, right? And then we get here and we start going up. Now we're traveling in the same direction as this guy.
Yes.
But remember, you can pick any direction for this in between or whatever, but just make sure you pay attention to the direction of travel, right? So we hit this negative to positive, right? Is what?
Negative.
Negative, because we're hitting negative first, negative 8, and then we hit this guy, and we're in the same direction as the current here. So we have plus 1 into I3 minus I2, I3 minus I2 equal to 0. So we have this as what? Rearrange. We don't have I1, right? So I can write 0 I1, no I1. I2 is only this guy. So minus I2, right? I3 is this and this. So 5I3 plus I3, 6I3 plus 6I3. And then 6 minus this is minus 2. Then we add it to both sides. Add 2 to both sides, we have 2. This is our equation 3. Now we can just use any method, preferably, well, this first equation is, the first one is I1 and the second one is I2. It's a mistake because we have just this, yeah. Now I'm going to bring out the equation down here, and you can use any method to solve 1, 2, and 3 simultaneously, right? So I'm going to write them here first. 12 I1 minus 2I2. I'm writing equation 1 plus what? 0 I3, because no I3, right? And then next equation is minus 2I1 plus 7I2 minus I3 is equal to minus 8, right? And then the last one is 0 I1 minus I2 plus 6I3 is equal to 2. We're going to solve them simultaneously. You can decide to just do RREF. You can do reduced row echelon form for the augmented matrix. augmented, you can use your calculators. And this first one will be 12 minus 206. So 12 minus 206 minus 2, 7, minus 1, minus 8. Minus 2, 7, minus 1, minus 8. And the last one is 0 minus 1, 6, 2. 0 minus 1, 6, 2. When you reduce it to the reduced row echelon form, let me see your original matrix. So by doing that, we get our I1, I2, and I3 equal to, let's see that we didn't enter anything wrongly. Okay. Yeah, and what did that give you? What's the final answer?
The final answer.
Uh-huh.
I1 is 0.3.
On dot?
Yes.
Exactly 0.
Nothing. 0.32.
Can you give me in fractions?
Okay. Okay. I will give you in fraction. 77
Mm-hmm.
over 234.
Mm-hmm.
I2 minus 40 over 39. I3 equal 19 over 117.
Hold on. This cannot be correct. I'm looking at your first answer and comparing it with the two answers, the first equation. Can you check again? It is not correct. This is 12 minus 2, 0, 6. Oh, it's possible. Okay, I guess it's fine. Okay, the last one is what?
19 over 117.
19 divided by 117, and these are current, so the units are ampere. So this is the way to go about mesh analysis. Just if you're following my video and you want to use it, just double check that we didn't make any mistake in our calculations here, but I don't think, I just like nicer looking answers. But yeah, we followed, if you find a mistake while watching the video, just point it out for us. I appreciate. But yeah, this is how you do mesh analysis. It's essentially a combination of KCL for the inner branches with resistive element and defining a mesh current for the outer branch, and then apply KVL. And that's it. That's how simple it is. Our subsequent video will have mesh analysis with a super mesh. A super mesh is when you have a branch in between two mesh or two loops with a current source, either a dependent or an independent current source. So we'll do that in a video that would follow this one. Thanks for watching, guys.